Good morning, Dr. Rebelo and everyone present in class today. My name is Sofia Saldivar, and along with my teammates Sabrina Folk and Typhoon Carriel, will be presenting book number 8, Clock Speed, Winning Industry Control in the Age of Temporary Advantages by Charles Fine. Unfortunately, none of us could be present in class. However, we've prepared a nice presentation for you all. Let's start with the agenda of our presentation. We'll talk a little about the author's background. We'll present the main ideas of the book, some clock speed concepts, as well as clock speed measurements and examples. We'll also discuss about industry dynamics, the Intel case study, and the clock speed on today's industry. And finally, we'll go over some conclusions and recommendations. Charles Fine is a professor of operation management and engineering systems. He is the co-director of the International Motor Vehicle Program at the MIT Sloan School of Management. He also works as a consultant for important companies such as Intel, Motorola, Toyota, 3M, and many others. His research is mainly about supply chain strategies and value chain road mapping, with a particular focus on fast clock speed industries. In the book, Professor Fine, instead of focusing on the monitor of the supply chain of slowly evolving businesses, he would speed things up by studying the industrial equivalents of fruit flies, which have a lifespan less than 2 weeks and can reveal much about successive generations in such a short period of time. Professor Fine emphasizes that the real core capability of an industry relies on the design and management of a supply chain in order to gain maximum advantage, which is usually temporary because of the competitive market that may change at a lightning speed. The book starts with an interesting comparison that Professor Fine makes, and we thought it was interesting to discuss. Well, he compares some industries, the fast clock speed industries, with the fruit flies. And just as I mentioned before, the fruit flies go from egghood to parenthood and to death in just 2 weeks. Therefore, they must genetically respond to changes in their environment quickly or face brutal extinction. In the business world, the fruit flies are industries where the natural life of product is short. New product introductions come at a fast pace, and companies need to constantly innovate or they be pushed aside. For example, movie studios and retail electronics are fast clock speed industries, while on the other side, automobile and airplanes companies are slow clock speed industries. The development of the book continues based on the genetics studies of fruit flies, where Professor Fine develops an insightful interpretation of the ways product design, process technology, and supply chains define the evolution of an enterprise and an industry. In addition, the book also offers some few case studies of some companies that have either succeed or fail in anticipating and adapting to a rapid change. Along with the main concept of clock speed, the book also talks about many other important ones like supply chain and value chain, how products and processes fit within the supply chain, core competency, integration versus modularity, dynamic changes in the market. We believe if these are well understood, it will actually help companies to gain competitive advantage. Now let's just reinforce that the most important concept to learn is about clock speed, which dictates the speed at which new life cycles evolve. Additionally, it describes how top performing companies are able to quickly anticipate where lucrative opportunities are likely to arise. So far, we've seen that each industry has its own evolutionary life cycle or clock speed, and this is measured by the rate at which it introduces new products, processes, and organizational structures. For instance, process technology clock speed is measured by capital equipment obsolescence rates. To better understand this, for example, we have on one side Intel's company that, let's say, if they invest in a fabrication plant, this will probably be obsolete in about 5 years. While on the other side, Ford's engine plant could be actively productive for about 20 years when they may actually plan on regain their money. Now, for product technology clock speed, this is measured by the rates of new product introduction or intervals between new product generations. In this category, we can name Boeing's company, which actually launches about 2 new products per decade. And on the other side, now we have Disney Movie Studios that introduces about 1 new children's movie per year. So as we could see, Disney has a faster clock speed. And they actually adjust its cycle time to the time between new product introductions. Organizational clock speed is measured by the rate of change in organizational structures. This is that some companies might not be able to respond quickly to organizational advances or innovations in their industries due to the paperwork needed or some other reasons that puts them behind, not allowing them to be competitive. Assets clock speed is anything that it's not explicitly process technology, product technology, or internal organizational capabilities. 2 examples of these are distribution channels and brand names. The value of brand names, for example, like Coca-Cola and Tide detergent, became well known over time, probably decades. While Lexus, on the other side, developed a strong brand name in a shorter time period. As we can see, industry clock speed is dynamic, and technology innovations and competition can increase the clock speed within an industry. Now, I will let Typhoon take over to discuss some more important points.
Hello everyone, my name is Typhoon Karya. I'll be continuing this presentation with the section called integration. Clock speed talks about 2 different concepts, vertical and horizontal integration. Vertical integration is the acquisition of businesses within the different supply chains. Horizontal integration is acquisition of businesses within the same supply chain. Some examples for this will be in the 1970s and early 80s. The computer industry structure was vertical, where companies such as IBM tend to provide most of the key elements of their own computer system, from the operating system and application software to the electronic hardware. In the late 70s, it started to become more modular. Next concept is called double helix. It comes from molecular structure of DNA in genetics. The author makes a relation with this. Double helix is a model based on an infinite double loop that cycles between vertical integrated industries inhabited by corporate behemoths and horizontally modular industries populated by myriad innovators, each helix seeking a niche in the wide open space left by the earlier departure of the giants. The business double helix illuminates how these vertical and horizontal eras determine the fate of the companies, industries, and sometimes the economic future of the nations. There are three forces behind the double helix. First one is the relentless entry of niche competitors hoping to pick off discrete industry segments. Second one is the challenge of keeping ahead of the competition across the many dimensions of technology and markets required by an integral system. And the third force is the bureaucratic and organizational inflexibilities that often settle upon large established companies. Analysis of a company's supply chain determines the core competency within the industry and throughout the supply chain, as well as the strengths of the supply chain. The power of this mapping lies in the shocking discoveries one will make, discoveries that can help one to avoid potential crisis down the road if one takes the necessary steps now to correct the problems.
And there are three different chains or value chains mentioned in clock speed. One of them is organizational supply chain, the other one is technology supply chain, and the third one is the business capability chain. And they are used to reduce risk by revealing risk and opportunities.
Industry dynamics. Clock speed may not be stationary within the industry. Clock speed may not be well defined at the industry level since many industries are composed of others. Applying the lessons of the fruit flies to the industry as diverse as bicycles, pharmaceuticals, and semiconductors illustrates how competitive advantage is lost or gained by how well company manages a dynamic web of relationships that run throughout its chain of suppliers, distributors, and alliance partners.
As we continue to industry dynamics, understanding other clock speeds helps manage supply chain upstream and downstream. The closer the supply chain is to the customer, the faster the clock speed is. Below graphic illustrates the amplification from supplier to customer, which is a great way to transition into two different laws, supply chain as described by the clock speed.
First law that's described in the book called Clock Speed is volatility amplification, where the volatility of demand and inventories in the supply chain tend to be amplified as one looks farther upstream away from the user, which is also known as bullwhip effect. Second law is the clock speed amplification. As you move closer to the end customer in the supply chain, the clock speed increases, sometimes dramatically. And another concept that's described in the book is called 3DC, or three-dimensional concrete engineering, where traditional concrete engineering, product and process, is combined with supply chain from the beginning of the product lifecycle. Another concept that's covered in the book is make versus buy, which is a very important concept. The 2x2 matrix shown below suggests how product architecture and outsourcing strategy interact. When a product has a modular architecture, it can typically be decomposed into subsystems that are relatively easy to outsource. If a company chooses to outsource both the manufacturing and the design and development of such modular systems, the upper left quadrant of the figure suggests that such a decision might create the opportunity to price gouged by the supplier. As we continue with the make versus buy concept, four-dimensional metrics with four kinds of interdependencies are technological, organizational, intertemporal, competitive. The second image
where potential suppliers and their relative clock speeds compared, further sharpens this intuition mentioned earlier. For example, where clock speed is fast and potential suppliers are few, by outsourcing the modules, the company may risk losing control of key performance determining subsystems. Implementation of three-dimensional concurrent engineering. Companies are able to implement three-dimensional concurrent engineering, giving clock speed, core competency, firm understanding of product, process, supply chain architecture, industry dynamics, dependency, decomposability, and make versus buy. The increasing clock speeds in our economy are forcing firms to launch products more frequently, which in return forcing companies to compress their product development cycles. To be able to launch new products successfully and more frequently in a short amount of time, three-dimensional concurrent engineering can be implemented by following 5 tools: design for manufacturability, project scheduling, design structure, process bottleneck identification, customer requirements.
This book contains many case studies of how the decisions used to develop the product, process, and supply chain design can also impact companies in their entire industry. One recurring example the author refers to throughout the book is the emerging personal computer industry from the 1970s and 1980s. In the early 1980s, IBM dominated the supply chain with integrated products and subcomponents. However, due to the entrance of other PC makers into the market, IBM realized it had grown over time into a large, rigid organization. They were unable to react swiftly and keep up with competing forces. So, IBM decided to outsource some of their subcomponents that allowed compatibility with their PCs. Intel and Microsoft became dominant in their niche markets and took advantage of the new modular and compatible PCs designed by IBM. So Fine pointed out IBM's failure to understand the core capability of the PC industry and their decision to focus on hardware integration instead. Fine also pointed out IBM's decision to outsource processors to Intel and operating systems to Microsoft, which they both grew to be very important parts of the value chain map and overall supply chain. These events ultimately led to a complete restructuring of the computer industry, the PC supply chain, and ultimately led to IBM's fall from dominance. IBM did not understand the clock speed of how fast new concepts and technology evolved in the growing PC industry, and they misunderstood and eventually outsourced their core capability that provided them a competitive advantage. This is to say, they chose to focus on the slower clock speed of manufacturing hardware rather than the fast, innovative clock speed of developing software. However, Intel and Microsoft did understand these concepts and took advantage at the right time by branding themselves separately from IBM. They designed products that became compatible with other systems besides IBM, which allowed customers flexibility of choosing different PC makers while still getting Intel and Microsoft subcomponents inside. Customers began to switch loyalty from IBM to Intel and Microsoft, as IBM was not a major decision when considering PC purchases. The author refers to this phenomenon as the Intel Inside phenomenon. Industries where slower clock speeds, such as the car industry and aerospace industry, can learn from the PC industry by avoiding the Intel Inside phenomenon. So, Fine makes observations of events that occurred over 15 years ago when the book was first written, like the IBM case just mentioned in the previous slides. But a brief case study into Apple allows us to observe how the principles of the book affect industries with emerging technologies within the past few years. We see how Apple maintains competitive advantage with the fast-paced emerging technology of mobile devices. Apple's supply chain is based on a modular structure where they outsource capacity by producing products in China. This allows them to focus resources on their core capability. They are able to dominate the supply chain and reduce inefficiencies by relying on advances in information technology that increase the flow and speed of information throughout the supply chain. They also make sure not to outsource their knowledge to a company that could steal their dominance over the supply chain. In contrast, Apple products and processes are based on an integrated architecture. For example, iPhones and iPods are incompatible with outside systems unless Apple dictates its usage. But for a majority of the decade, they were able to outpace competition in terms of innovation, introducing new products, and increase product sales, making the integrated product model sustainable. However, some companies with modular product designs, such as Android-based phones and PC-based computers, recently launched products that outperform Apple products. Tech-savvy customers want the flexibility to customize devices and the convenience to interoperate with other systems. And when the widespread use of the internet, quickly emerging technologies, and globalizations, niche markets are producing apps, batteries, screens, and connectors better and faster than Apple. Competition is growing due to increased technology and globalization, so niche markets are growing faster than ever before. This increases clock speed, and Apple, like many other established companies, may be unable to keep pace. This scenario forces Apple to determine the decision to make or outsource, or even buy a niche company and incorporate their design. Whatever decision they choose, they must ensure that they avoid the Intel Inside phenomenon. In conclusion, just as geneticists study the fruit fly to gain insight into evolutionary paths of the animals, managers can study industries with fast clock speed to gain a temporary advantage as well. The core message is that the long-term success of an organization is to always evolve and grow, looking for the next capability or advantage to exploit, because all advantages are only temporary. Technology is always emerging and evolving, therefore clock speeds are always increasing. And in turn, competitive advantages never last long. Fine also argues that the long-term success of an organization is highly dependent on making supply chain design a key part of its core competency. Recommendations include looking at other fast-moving organizations to try and see how it relates to your organization, understanding and assessing supply chain, and then mapping them to your organizational capability and technology chain to exploit that best advantage. Then, implementing 3D concurrent engineering to better align the company's product, process, and supply chain strategies. And last, aligning processes so that the faster clock speeds lead to a better competitive advantage. Thank you.